Okay, folks, okay, all the way. We've been talking about electric fields. So now we just want to talk about field generated, which is sometimes you have a field which is generated from what's called a point charge, something which is circular or round. And so like the Earth is round and it has these field lines that come in like this, and they get closer together as they approach the Earth because and that also represents the strength, by the way. That's a good way of representing the strength of something. We have the round Earth, and we have these lines. You can see that they're closer together when you get down near the Earth, which is true because the field increases. So field density gets a little closer down here, so the lines are closer together, so the field's stronger. If we're out here, boop, boop, opposed to here, boop, boop, look at the lines. The lines are farther apart out here, which means the field is weaker. Weak. And when you get down closer, lines are closer, strong. All right, so that's what we got going on around a circular thing. The same thing is true when we have, what kind of charge would this be? What kind of charge? Look, I'm keeping the lines the same. Negative, good job. Negative charge. And the same thing would be true around a circular charged particle. You would have the strength being closer, the strength being greater than when you're farther away, and the lines depict that. Farther away the lines are, the weaker the field. Okay? Farther away the lines, the weaker the field. But we also have a different kind of field lines that aren't always going away like this. If we have something generating an electric field, that might be like flat. Like the Earth? That's not really the Earth, that's the Earth. I believe that's the Earth. Billy, after all we've been through, oh no, you know what? We're starting back from scratch here, Billy. Come on. I'm just kidding. I don't think he is. I don't think he's, okay, let's move on. Flat thing generating a field, which can be generated from something called a capacitor, which coming up soon in a video near you. Yeah, we'll talk about capacitors. But anyways, you can get things which are flat that generate electric fields. That's my point. My point. Okay. Yeah. So when things are circular generating an electric field, you got field lines close, down near the object, farther away, and so the field strength varies depending on how far you are away from that object, that circular object. In a flat field generating thing, let's say that this plate down here, maybe it's a metal plate, and it's generating an electric field, and it's positive down here, and I'll put a negative plate up top. This is actually what I'm doing is I'm drawing something called a capacitor. It'll make more sense when you see a capacitor video. For now, just go with it. Go with the flow here. Work with me, people. Out of the positive, still holds true, into the negative. So I'm drawing my field lines out of the positive into the negative, but look at them. They're parallel. Okay, those are parallel field lines. This is called a uniform electric field. A uniform electric field. Why is it called a uniform electric field? Because the distance between each one of the lines is the same. So it's not varying. Because the strength of the field is the same anywhere within this area between the positive and the negative. All right, now here, it's not a uniform field. Because out here, again, this is going to be a weaker field. The lines are farther apart than here. So if I go from here to there, the field strength decreases. If I go from here to there, the field strength is still the same. The lines are nice and parallel to each other. So I'm still equidistant when you see. Now I'm not equidistant from these lines here. Up here I'm farther apart, but here we're the same distance. So therefore that's called a uniform electric field. And in a uniform electric field, the field doesn't change in strength as you move from one region to another within the field. But out here we move away, just like we move away from the Earth, it gets weaker. The strength of the field would get weaker. All right, I want to point that out. We will come back to this drawing when we talk about capacitors, and it's coming up soon, kids, coming up soon.